Yeah, I guess we spend too much time with LLMs, huh?
I think so.
We should really get out and touch grass.
The Shift, Agentic Edition, connects the people building AI tools with those creating agents so we can all level up together. Today, we're taking a beat with the Microsoft Foundry team, Allison, Pamela, and Matt, to talk openly about a question we heard from you. Is context engineering the new RAG?
So today we're going to dive into the topic, what makes an agent knowledgeable? So when I first think of knowledge for agents, I immediately think of RAG. However, we're in this era of agents everywhere, and I keep hearing that RAG is dead. So can you tell me what RAG is? Is RAG dead?
Okay, so RAG is Retrieval Augmented Generation, and it's definitely not dead, even though everybody likes to say that. So the idea of RAG is that we want LLMs to be able to accurately answer questions. So what we do is we look at the question, we go and then retrieve some information to answer that question. And this way the LLM can synthesize all that information, use its ability to have really fluent natural language, and give us a great answer to the questions. That way, we're getting the best of both worlds. We get great conversational fluency, information synthesis, and we get accurate information for our domain. So that's RAG. And then there's agents, right? You're saying this is like the year of agents.
What's an agent?
Right. An agent is an LLM that uses tool calling in a loop in order to achieve a goal. LLM has access to these tools. It looks at the question and says, oh, okay, like with these tools, I'm going to call this tool and pass these arguments, and that way I can get the answer. So there we have RAG, we have agents. So is RAG relevant in the age of agents? And it's definitely relevant because you give it a tool that knows how to fetch information from your database. You give it a tool that knows how to fetch stuff from the web. You give it a tool that can search your issue tracker. That's all retrieval, right? So we are still doing RAG like 90% of the time.
So in the era of agents, RAG isn't dead, it's just more sophisticated.
Yeah, I really like what you said about tool calling, right? Because now we're graduating beyond chats and we're actually having our LLMs take action in the world. And that really, to me, is what agents are all about. And I think the key thing about the connection to RAG is that these agents are very smart, right? We know that LLMs are trained on the internet and they know a lot of knowledge, but they don't know a lot about your specific task. And what makes them really remarkable is these LLMs, they have something called the context window. Okay. So here's where it gets really interesting, is that when you prompt an LLM, right, you're just writing in a message, you're putting that message inside what's called the context window, which is basically all the inputs the LLM can take. Context is just kind of, again, any of the information that the agent is going to need to do its job. And really, the hard part about building an agent is about making sure that you have exactly the right context. Like previously in the very beginning, they can only be looking at what we call tokens, which are basically just fragments of text and images. They can only look at a couple of them at a time, and they weren't super useful. But now you probably hear there's new models with millions of tokens in the context window. And even though they have that massive context window, there are still kind of limitations with the ability to understand it. So finding that high quality context is really important. Once you have that right mix of knowledge in the context window, that's really when you unlock the magic of agents and they can start being really useful and be more of a colleague or a tool for you to do your job.
But the context can also include the conversation history. It can also include, if it's an agent, whatever tool calls it's done in the past as part of the history. And then there's also this newer notion of memory. So then as I'm having conversations, it can make better recommendations. It can answer questions better based off these facts that it's learned about us, right? We're giving it the conversation history. We're giving it the tool call results. We're giving it any relevant memories that we have about that person that's going to help the LLM best answer this question.
Connecting RAG to context, it seems like context is just a new retrieval problem.
I think context is just a newer term, right? So I think you're using the term context more. You're going to hear the term context engineering a lot more.
It's interesting how things have evolved, and like a lot of the techniques and the foundations of prompt engineering have really been the foundation for context engineering. But at the end of the day, it's really about the information you're putting in the prompt. Am I setting a clear example for the LLM? Does it understand what is it supposed to do? What is it not supposed to do? And it's really enabling you to build a more effective agent that can actually go and do stuff, and it's not just a chatbot that's responding in a funny way.
When I think of retrieval, the first thing I think about are vector databases and vector retrieval. How should I think about vector databases in this era of context? Can I just buy a vector database and that will help me ensure that I'm getting the right context to my LLM?
So vector databases are really, really cool because they allow us to do semantic searches for things, right? So, if I'm searching for a purple shirt, I can also get back a mauve shirt or a heliotrope shirt or whatever, right? Like things that are semantically similar that are not the same words, and users are able to describe their things with much greater terms. And I really love it because also it allows us to support users coming from other languages, right? Because a lot of our technology has been very English-centric, but many of these LLMs and vector embedding models are trained with multilingual corpus, which means that then suddenly we can start having people type in their queries in Spanish and then they can actually get answers, right? But vector search is not enough. And I've written blog posts with that title. I give talks about this every month because developers keep saying all you need is a vector database, and it is not true at all. And I'm begging people to add more to their search stack. So luckily, Foundry IQ does have a really full-featured tech stack.
When Foundry IQ was first created, it actually kind of began life as a pure text search engine, right? There's a search bar. There might be some checkboxes on the side for what type are you searching for. And this was kind of the foundation of how Foundry IQ really got started. And anyway, that's still relevant today because a lot of times if you're searching for something, how many times have I gone to the hardware store being I need a screw and it's a specific length. And if I was semantically searching that screw, I'd find a lot of interesting things, and I like picking through stuff, but I really just want a specific screw. And that's kind of one of the weaknesses of semantic-based searches is that it's not exact.
Right. We do that example all the time with our sample data is a hardware shop, right? So we're always doing these searches. So if I search for a 25-foot hose, it returns back a 50-foot hose and a 75-foot hose, and then finally way down there's that 25-foot hose, and that's what happens if you only use vector search.
So you're telling me that vector search is not enough, text search is not enough, I need both.
That's exactly right. So in Foundry IQ, we put them together using a technique, fancy name, reciprocal rank fusion. Really all it is just merging two sets of search results together. So what happens is text search and vector search kind of fix the weaknesses of each other, and you end up with a really good match for whatever the query is. We're not done yet. So now that I have my kind of candidate set of documents, we've found stuff that is relevant to the query, but it might not be the best fit. So the order of the list could be adjusted. So we in Foundry IQ have actually trained a much smaller model. And again, fun fact, this was around way before LLMs. It's called a ReRanker. And the core idea behind it is that it's actually reordering the results based on the actual query being searched. And this provides a really significant boost in quality. And connecting this back to agents, when you have re-ranked hybrid search results, you're making sure that the best fit for the query that the agent is searching is ending up in that context window, which is so important, especially because your agent is thinking about so many other things.
And there is one more benefit of the re-ranker. So the re-ranker assigns a score between, is it 0 to 4?
Yeah.
Right, so it assigns a score to 0 to 4. And it's based off humans that trained it. And humans would look at search results and they'd look at queries and say, oh, I think this is 4, this is the best for this query. query, right? So that's the other nice thing, because vector search and keyword search can both find completely irrelevant results, right? Like vector search, you think in vector search, you search for something and you're basically like, you're in this multidimensional space. I always picture like an ice cream cone. But anyway, you have all these vectors in multidimensional space and you have the target vector and you're trying to find the vectors close to it and you get like the 10 closest vectors. Well, it could be that the 10th closest vector is actually like way over here. But you got it because that was a 10th closest vector, just because there's not that many similar things to your question if you're asking something really weird, right? And you still got that back, right? So that's like a noisy result for vector search. And then keyword search can also give back noisy results because like it'll just be like, oh, I did match that term. Like for the hardware example, if I search for 25-foot hose, I then get back 25-inch drain snake. And it's like, how am I going to use a drain snake to water my garden, right? So it's irrelevant, but it matched because of that 25, right? So with the ReRanker, if we set a threshold, we can just drop it if it's not high enough.
So with context engineering, the main goal is to provide the LLM with the most relevant and only the most relevant content for that particular query. And hybrid search is one way to reach that goal. And then you add ReRanking as well, which will give you only better results from that.
As we kind of evolved Foundry IQ for the age of agents and context engineering, we thought what are all the things you need to do to build a context engineering pipeline? We need to know if we have a query, how do we get relevant results for it? How do we even know what to query? It will select the different sources of knowledge that you need to go look at. It will fetch from those knowledge sources using state-of-the-art retrieval technology. It will merge the results together. It will figure out if it needs to go plan another round of queries. And did I find relevant documents, or were the documents off base and need to be removed? Because managing that context window is so critical. So it's really a kind of multifaceted, complex problem. And the benefit of kind of encapsulating it in a single knowledge base is that now as you build other agents, you get to reuse that knowledge base. So you can avoid reinventing the wheel every time you build a new agent.
And you use an LLM for that stage, right? Where the stage where you're trying to decide whether you need to go and do another search. How do you decide that?
Yeah, so it's really interesting. So an LLM definitely plays a role. And this is kind of a trade-off that anyone developing an agent makes. So LLMs that are really smart aren't particularly fast. There's a lot of techniques that people do, like maybe they're going to be streaming output from the LLM. Maybe they're going to be like, hey, I'm going to like cache something to make it faster. But for the most part, there's a lot of additional latency. So what we decided to do was we decided to actually use a process called distillation, where you take a really large model and you take some task that's performing and you basically gather a bunch of data about how it did that task. And you go and you actually take a much smaller LLM. We call them SLMs, small language models. And we actually fine tune that SLM to do almost on par with a larger model. It's really a remarkable technique, and it allows you to get a lot of extra mileage out of smaller models. Because we're building a content engineering pipeline, we said, hey, we have a very small model that looks at the documents, looks at the query and says, is this actually enough to go answer the query? And if it decides, I need another pass, it's going to trigger another query planning process that's taking into account the documents we found.
Even with the full retrieval stack, you have hybrid, you have ReRanking, you still only had one shot to get the most relevant information to a query. But now with knowledge bases and with agentic retrieval, you're now able to try again and make sure that you are getting the right information and providing the right information in more than one go.
Yeah, I mean, I think at the end of the day, we realized that retrieval as it was is very human driven, right? It's like, I think I know what I'm searching for. I go search, I go find some information, I'm gonna look at it, and then I'm going to do I need to keep searching, and do I change my query based on what I found? And we really tried to recreate that experience as the agentic retrieval product.
It uses agentic retrieval to deliver the right context for your agent. The main thing I hear from customers is, wait, agentic retrieval, I'm still getting used to RAG, I'm still getting used to connecting my data to my agent. What do I need to do? And I also hear, I don't even know if my agent is performing well. how do I know that my agent is actually giving me the right answers? So can you tell me a little bit about how we should be evaluating agents and making sure that they're actually doing what they're supposed to do?
I'm glad they're asking those questions, right? I would be more concerned if nobody ever asked you that, right? So yeah, a lot of times when developers are first, like when they're building agents, they have some like their favorite questions that they send to the agent, right? LLMs can be convincingly wrong. The only you have to even have a human expert that knows the data that's in that data set that says, yes, that is a correct answer for that question, or that's wrong in some way.
Your agent is performing as it should. You need to be measuring it for groundedness and for relevance. And regardless of what you do, what tweaks you do to the agent overall, you're going to keep those same metrics steady and consistent. So to be able to see if that change did anything to affect those scores.
Yeah, that's a great start. Those are the two most popular metrics that you'll hear about for RAG applications specifically is groundedness and relevance. So you definitely want to start with those metrics. What a lot of people do is they get started with those metrics and then they start to actually analyze, production use cases and see, and have a human go through it that has domain expertise and have that human annotate and say whether they actually thought it was correct and in what way it failed. Because then you might determine your own metric. And humans tend to score things highly if they sound good, even if they're inaccurate. So the fascinating thing is that you'll see these, like the RLHF metrics, you'll see that helpfulness, the ranking goes up, but hallucinations also goes up at the same time. And so, LLMs have been trained to please us. And humans like to hear what we want to hear. And that's, we have to counter that sometimes because we want to give people accurate information. So I actually love the fact that GPT-5 realized this, and specifically during their training, they sacrificed helpfulness in favor of accuracy. And I'm hoping more of the models do that because I think accuracy is increasingly important.
A really common thing you'll see in a lot of LLM-based applications is they'll have interactive clickable links in the answers that are generated. And that really gives people the confidence that this is not made up, that if I really wanted to, I could read a page and I could find where the answer is.
So one, I do think is a best practice. We should provide citations. We should also assume 99% of users are not going to click through those citations, right? We're all too lazy. We're not going to do it. So we do, that's why we do really need to do these evaluations to really determine whether we're giving back good results. So for the prompt for the RAG application, what I say there is if the sources are not sufficient to answer the question, indicate that you don't have sufficient sources. Say, I don't have full information for these sources, and you can also indicate whether you have partial sources available. So it is really helpful to tell it, if you tell it exactly how to handle the situation of not having complete sources, then it knows what to do.
It seems like there could be a major security risk with that. How do you make sure that every user is able to use the agent and based on the information that they're allowed access to?
So the interesting thing here is if you're an organization and you're using Foundry and you're using Microsoft products, chances are you already set up your security through Entra. Just thinking about it as hey, who's a member of my organization? What role do they have? Are they a member of some security groups? Do they have access to specific things? The great thing about Foundry IQ is that all that same exact access kind of flows through so that documents are actually able to be marked with, here's a specific user who can access it. Here's a specific group that can access it. And we chose to make this more of a retrieval problem and less of an LLM problem, because at the end of the day, the best way to make security a natural part of agents is to put it at different parts of where the agent's getting information from, not at the prompt part, rather at the retrieval part.
That shocks me that anybody even thinks you could do it at the prompt part, because we've seen that you can even find out what data the LLM was trained with by probing it enough. So how could anyone imagine that you could hide anything in the prompt? Is crazy to me.
I think LLMs are very helpful, and you chat with it a little bit and you don't evaluate it, you kind of get a different idea of its actual capabilities. So.
Yeah, I guess we spend too much time with LLMs, huh?
I think so.
We should really get out and touch grass.
Speaking of grass, MCP. What is MCP?
Unclear the connection there, but great transition. I mean, MCP, it's so big right now. I actually went to MCP Night, very close to here, a month ago. It was the fanciest tech event I'd been to. So to give a feel for like how big MCP is, like this MCP Night was cocktail attire. I've never been to a tech event with cocktail attire. I had to buy these boots for it. And I had to buy everything, but it had a lookbook and everything. I think it was an AI-generated lookbook. But anyway, so MCP is so big that it's warranting fancy events, 2,000 people, and they said they're going to like move to like the Oracle Stadium next or something because of the amount of people interested in it, right? So it stands for Model Context Protocol, and it is a standard protocol which is the way that we can give more context to agentic applications. Okay, that's like a mouthful. So it came out from Anthropic's Claude Code first, which is that they wanted a way that people using Claude Code could bring in more functionality in order to make Claude Code more powerful. And then once you have an MCP server, since it's a standard, then like once that MCP server is working in GitHub Copilot, then you can also bring it into anything that understands MCP, like all the agent frameworks, right? Like, LangChain or Foundry agents, right? They all understand MCP as well. So it then becomes this way that, like, just a common way of exposing like an API surface.
Okay.
So that, any sorts of agentic applications can use the same tools and be able to be more powerful for, different workflows. So yeah, it's really big and it's pretty exciting. So as a developer, you might start thinking about when you're building an application, does it have to be an actual user-facing application, or could you just build an MCP server, right? Like, could you just expose this, this information via an MCP server? In the future, maybe you'll write your MCP servers before you write your front end.
So going back to the original, what's an agent, right? It's being able to use tools to take action in the world. And to me, MCP is really all about where are those tools located? Are they running right alongside the LLM, or are they somewhere else? Hey, I go to bing.com, I go to microsoft.com, I'm accessing a resource over the web. Agents can now do the same thing and then be able to have their capabilities enhanced. So when I think about the exciting thing about MCP, and what does that mean for context engineering, right? So you can add that capability to any agent, can now use that context engineering pipeline. And we're also working on adding other MCPs as knowledge sources to Foundry IQ. So it goes both ways. You can reach out to other things that we never thought of when we built Foundry IQ. It's like, maybe you want to do context engineering and you're using another platform, like, hey, I want to use something with Jira. I want to go to Wikipedia. And you can basically just plug in new integrations that, because we have an LLM mediating all these interactions, it can just figure it out. And that to me is really exciting.
So it's just MCP all the way down now.
Yeah, I mean, I think MCP is like, the great thing about it is it's like the USB-C of AI, because it is one plug that you can put anywhere and it just kind of gets extended.
I saw this really interesting talk from a front-end engineer, and he's thinking about it really interesting because he's trying to figure out what is front-end engineering in the future. And he thinks that front-end engineering kind of might go away the traditional way we think of it, because right now we think, we want to provide a service, we're going to build a website, and that website's going to, have like a navigation menu. But he's thinking in the future, we might be building MCP servers first when we provide a service, and then you go to, your favorite agent. You say like, I want to book a ticket. And that's going to use like the ticketing MCP server. And then you never have to visit a website. Okay. So you could still have a little bit of visual, right? You need a map. Okay, here you go. Here's a map, right? So you still can have visuals. It doesn't all have to be text. You want to see like the picture, like you say, I want to like search for cool purple shirts for this podcast, right? You can still like see those images there, but you're interacting entirely over chat with this, shopping server over MCP. So that's a potential future version of the web, which
so maybe cool. RAG's not dead. The web interface.
The web is dead. Yeah, the web is dead. But
Dead.
So you're going to have to throw some cold water here. human verification is never going to go out of style. And when you build an agentic application, yes, think about what to build first, but having an interface where humans can at least check and correct agent work, I think is really important.
Well, I mean, I think I agree because Copilot, they're all user-facing interfaces, and they do keep a human in the loop. It's just a different interface for the human being in the loop. How do we present different results to users? Like Andre Karpathy gave a great talk where he said, like, every interface needs a way of showing a diff, right? When we're doing code, we see, like, when the agentic coding tool makes a change, we can see the diff, right? Imagine that for everything. Everything needs a way of showing you the diff so that you can confirm or accept or iterate, right? So if you're using the, you're using the agent to create a PowerPoint presentation, you ask the agent to make a bunch of changes to the PowerPoint presentation. What is the diff? How do you visualize what changed in that PowerPoint presentation so that you can have confidence that you liked what the agent did?
Yeah, I mean, I think it's up to all the builders out there to make these kind of tough decisions. And we're really excited, I think, about the ability to give agents better context so that they can do the work, but there's a lot of open problems still to be solved.
Yeah, I think if we can find really good ways of keeping humans in the loop and empowering them with enough information to figure out whether they liked what happened. Mm-hmm. People are working in so many different domains, and they come to us with like the most fascinating documents. They're like, okay, we've got this Excel file and it's like semi-structured and there's like diagrams over here and tables are there. Da, da. How do we ingest this? Like, that is a really good question. Here's some ideas of how I might start off with that, but you're really gonna have to experiment with that and then do evaluations, right? So I think like the high level is, you're going to do some content engineering. You want to put some, rigor into that. You want to figure out what's going to really work for your domain and see how you're going to evaluate that. And we've got a lot of really great retrieval techniques. We've also got a lot of great data ingestion techniques that you can use for more complicated data. And, you're going to play around those and see how you get best results. And it's really fascinating. Like, it's a really fun space to work in because you kind of start to understand like both how powerful these models are and that they have these like really interesting limitations, right? You always talk about the jagged edge.
Yeah, when we talk about models and we talk about how smart they are, like, it's really impressive how they can get a 1600 on the SAT. They're the smartest person around.
I also got a 1600 on the SAT. I feel the need to mention that.
You could be an LLM.
That's amazing.
I'm very good at pattern recognition.
It's amazing.
So when you talk about model intelligence, you're talking about a model that scores really well on any standardized test, not just the SAT, but also doesn't necessarily know how many letters are in a word, like strawberry. Mm-hmm. And I think the builders who are figuring out how to really get the most out of these models are the ones who are like, okay, where are the strategies that work? And how can context engineering really help me overcome the model's limitations and let me get useful work done?
Thanks for hanging out with us. Check out the link below to get the latest Microsoft Foundry ebook. See you next time.